This is not science fiction. This is the universe, immense, violent, and utterly awe-inspiring. Welcome to Space Frontier Ventures. Join us as we voyage to the farthest, strangest, and most terrifying corners of existence itself. Great nothing is one of the most mind-boggling concepts in cosmology. Imagine looking out into space and realizing that vast regions exist where almost nothing exists. No stars, no galaxies, no nebulae, just an immense emptiness stretching across millions of light years. These regions are called cosmic voids, and they are some of the largest structures, or more accurately, absences in the universe. While space is often thought of as a dark, empty vacuum, these voids are extreme examples where matter is so scarce that they seem like the universe's version of a desert. The term great nothing evokes this sense of incomprehensible emptiness, a place where the cosmic landscape is eerily silent and vast beyond imagining. Despite the name, these voids are not entirely devoid of matter. Tiny amounts of gas, stray stars, and dark matter may still exist, but the density is minuscule compared to the bustling regions of galaxy clusters and superclusters. In fact, the contrast is staggering. While a dense cluster might contain thousands of galaxies packed into a region just a few million light-years across, a void of similar size might have only a handful of galaxies, separated by hundreds of millions of light-years. This makes them some of the most extreme structures in the universe, not for what they contain, but for what they lack. The scientific significance of the Great Nothing is profound. These voids are key to understanding the large-scale structure of the cosmos, often called the cosmic web. The cosmic web is composed of interconnected filaments of galaxies, with voids forming the empty spaces between them. Studying these emptiest regions allows astronomers to trace how matter is distributed on the largest scales, revealing the underlying scaffolding of the universe. Furthermore, voids provide clues about dark energy, the mysterious force driving the accelerated expansion of the universe. By observing how voids grow and evolve over billions of years, scientists can test models of cosmic expansion and the formation of galaxies, offering insights into the invisible forces shaping reality. Philosophically and visually, the Great Nothing is awe-inspiring. It challenges our human perspective of space as simply filled with stars and planets. Instead, it forces us to confront a universe where emptiness itself has structure and meaning, where the vast expanses between galaxies are just as important to understanding cosmic evolution as the galaxies themselves. In a way, the Great Nothing is a silent witness to the history of the universe, a reminder of the immense scale, the profound emptiness, and the staggering beauty of the cosmos. The Eridanus supervoid is one of the most enigmatic and hauntingly empty regions of the universe ever discovered. Located in the constellation Eridanus, this colossal void stretches across roughly 1 billion light-years, making it one of the largest known structures, or, more accurately, absences in the cosmos. To put that into perspective, the light from the Milky Way takes about 100,000 years to cross our galaxy, but the Eridanus supervoid is 10,000 times larger than our galaxy, a yawning expanse of near-complete emptiness. Unlike typical cosmic voids, which may still contain a smattering of galaxies, the Eridanus supervoid is particularly extreme. The density of galaxies inside it is far lower than the surrounding universe, creating a massive region where matter seems almost entirely absent. This has fascinated astronomers because it is not just empty space, it is a structured absence, a vast pocket carved out by the forces that shaped the cosmos. Some theories suggest that such enormous voids could be the result of quantum fluctuations in the early universe, while others consider them clues about the behavior of dark energy and the expansion of space itself. The Eridanus supervoid gained significant attention due to its possible connection to the cold spot in the cosmic microwave background, CMB, the faint afterglow of the Big Bang. Observations show that this region appears slightly cooler than the surrounding universe, a phenomenon that some scientists theorize may be caused by light from distant galaxies, losing energy as it passes through the supervoid, a subtle effect of gravity known as the integrated Sachs-Wolf effect. While the connection is still debated, The idea that a single void could influence the very fabric of cosmic background radiation highlights the sheer scale and mystery of the Eridanus supervoid. Beyond its scientific significance, the Eridanus supervoid is visually and conceptually staggering. Imagine floating in space and seeing nothing for billions of light years in every direction. A black abyss where galaxies are few and far between, as if the universe itself had carved out a hollow region. It challenges our understanding of cosmic structure and forces us to think differently about emptiness. In studying such voids, astronomers are not just mapping the universe, they are exploring the limits of what is observable, peering into regions where matter is scarce and the ordinary rules of cosmic density seem almost suspended. In essence, the Eridanus supervoid is a reminder that even emptiness has scale, shape, and significance. It is not merely a passive absence, but a silent sculptor of the cosmic landscape, a vast and haunting frontier in our quest to understand the universe. The Great Attractor is one of the universe's most mysterious gravitational enigmas, a cosmic force so massive that it tugs entire galaxies, including our own Milky Way, toward it. Imagine the universe as a vast, interlinked web of galaxies, clusters, and voids, all drifting through the cosmic sea. Somewhere in that expanse lies a region so dense and influential that it subtly directs the motion of millions of galaxies over hundreds of millions of light-years. That region is the Great Attractor, located in what astronomers call the zone of avoidance. A part of the sky obscured by the dense stars and dust of our own galaxy, the Great Attractor is incredibly difficult to observe directly. Its exact composition remains partly hidden from view, which only adds to its mystique. Scientists estimate that it contains a staggering mass equivalent to tens of thousands of Milky Ways, concentrated in a region hundreds of millions of light-years across. This gravitational leviathan exerts a pull so strong that the Milky Way, along with our local group of galaxies, is moving toward it at roughly 2 million kilometers per hour. The existence of the Great Attractor challenges our understanding of the universe's structure. It cannot be seen in visible light because of the Milky Way's intervening dust, so astronomers rely on infrared and X-ray observations to study the galaxy clusters hidden within it. Some theories suggest that much of the mass we cannot see might be dark matter, the invisible material that makes up roughly 85% of the universe's mass. In this way, the Great Attractor is not only a gravitational powerhouse, but also a clue to the invisible scaffolding of the cosmos. Conceptually, the Great Attractor is both awe-inspiring and unsettling. While it silently pulls galaxies over vast cosmic distances, it is fundamentally invisible to the human eye, reminding us of the unseen forces shaping the universe. We are participants in a grand, unseen cosmic dance, moving inexorably toward a hidden center whose mysteries we are only beginning to comprehend. In this sense, the Great Attractor embodies the universe's power and enigma, a hidden, colossal force guiding the flow of galaxies across the cosmic ocean. The event horizon of a black hole is one of the most mysterious and extreme boundaries in the universe, a point beyond which nothing, not even light, can escape. Imagine a region in space where gravity is so overwhelmingly powerful that all paths lead inward. Once anything crosses this invisible boundary, it is lost to the black hole forever, swallowed into a singularity from which there is no return. This boundary is not a physical surface, it's a mathematical threshold in space-time, a point of no return that marks the edge between the observable universe and the unknowable depths within. The physics at the event horizon are mind-bending. According to Einstein's theory of general relativity, gravity warps space-time, and the event horizon represents the point where this warping becomes so extreme that all directions up, down, forward, backward curve inward. From a distant observer's perspective, an object falling toward a black hole appears to slow down and freeze at the edge, its light stretched and redshifted until it fades away. Yet for the object itself, it crosses the event horizon without noticing any sudden boundary, plunging toward the singularity at the center. This paradox, simultaneously frozen in time for one observer and plunging inward for another, is one of the most fascinating aspects of black hole physics. Observationally, the event horizon is nearly impossible to see directly because no light escapes from it. But scientists have found clever ways to image it, most famously with the Event Horizon Telescope. By observing the glow of superheated gas and matter spiraling into the black hole, astronomers captured the first ever silhouette of a black hole in 2019, revealing the dark shadow of its event horizon against a halo of light. This achievement confirmed decades of theory, showing that these boundaries are not just abstract equations, they are real, observable features of the cosmos. Conceptually, the event horizon is terrifying and mesmerizing. It represents the ultimate cosmic limit, a reminder of how extreme gravity can become and how little control we have over the universe's most powerful forces. It is a doorway into the unknown, the line separating everything we can measure and understand from the realm where space-time itself breaks down. To approach a black hole is to confront the edge of reality, where the rules of physics as we know them begin to unravel, and where the universe reveals both its beauty and its absolute, indifferent power. At the very heart of a black hole lies the singularity, the enigmatic center where all known laws of physics collapse. Unlike the event horizon, which is a boundary marking the point of no return, the singularity is the point, or possibly a tiny region, where mass is compressed to infinite density and space-time curvature becomes infinite. Here, gravity is so intense that it overwhelms every force we know, warping the universe to an extreme degree and leaving our current understanding of physics almost completely powerless. Inside the singularity, space and time as we experience them cease to behave normally. General relativity predicts that all matter collapsing into a black hole is crushed to a single point, where density becomes infinite and volume effectively drops to zero. Quantum mechanics, however, suggests that the rules at these extremes cannot be fully described by classical physics alone, leading to one of the greatest unsolved problems in science: how to reconcile general relativity with quantum theory. In other words, the black hole center is a doorway into the unknown, a region where the universe's deepest secrets are hidden. The singularity's existence also raises profound questions about information and reality. According to classical physics, anything that crosses the event horizon disappears entirely, its information seemingly lost forever. This leads to the famous black hole information paradox, which has puzzled physicists for decades and has inspired theories such as Hawking radiation and holographic principles. Essentially, the black hole center forces us to confront the limits of what can be known and measured in the universe. Conceptually, the singularity is terrifying yet awe-inspiring. It represents an ultimate cosmic extreme, where density, gravity, and the very fabric of space-time reach levels beyond comprehension. While the event horizon signals danger, the center embodies the unknown itself, a place where conventional reality ends and only the profound mysteries of the cosmos remain. To think of a black hole center is to stand at the edge of understanding, staring into a realm so extreme it challenges our imagination, our physics, and our place in the universe. At the very center of the Milky Way galaxy lies Sagittarius A*, a supermassive black hole with a mass of roughly 4 million times that of our Sunday. Unlike the stellar mass black holes formed from collapsing stars, Sagittarius A* is a gravitational giant, anchoring the motion of the millions of stars that orbit around it and silently shaping the dynamics of our galaxy. It's invisible to the naked eye, hidden behind dense clouds of gas and dust, yet its presence is unmistakable through the precise observation of the stars dancing around it in astonishingly fast orbits. The region surrounding Sagittarius A* is extreme in every sense. Stars near the black hole can travel at speeds of thousands of kilometers per second, whipping around the singularity in elliptical paths dictated by its immense gravitational pull. Gas and dust spiraling toward the black hole heat up to millions of degrees, emitting X-rays and radio waves detectable by powerful telescopes. Though Sagittarius A* is relatively quiet compared to the luminous quasars found in other galaxies, it still embodies the incredible forces of nature, a cosmic engine quietly exerting its influence over light years of space. Observations of Sagittarius A times have provided some of the most compelling evidence for the existence of black holes. By tracking the motion of nearby stars over decades, astronomers have confirmed that nothing but a compact, supermassive object could account for their rapid orbits. The Event Horizon Telescope even recently captured the first ever shadow of this black hole, revealing the glowing ring of superheated matter around the dark silhouette of the event horizon, a direct glimpse of the abyss at the heart of our galaxy. Sagittarius A times is more than just a gravitational giant. It is the central anchor of our galaxy, a reminder that even the vast Milky Way is bound by invisible forces and dominated by a single, incomprehensibly dense point in space. Conceptually, it represents both danger and stability, a black hole capable of swallowing anything that ventures too close, yet also the quiet heart that keeps billions of stars moving in cosmic harmony. To study Sagittarius A times is to peer into the engine room of the galaxy, witnessing the profound and delicate balance that governs the dance of stars, planets, and the space between them. Dark flow is one of the most mysterious and puzzling phenomena in modern cosmology, a strange motion of galaxy clusters that seems to defy everything we understand about the universe's expansion. According to conventional cosmology, galaxies and clusters should move primarily due to the expansion of space, spreading apart uniformly from one another. But observations suggest that certain clusters are drifting together in a single direction at incredible speeds, pulled by something beyond the observable universe. This unexplained motion is what scientists call dark flow. The evidence for dark flow comes from subtle measurements of the cosmic microwave background, CMB, the faint afterglow of the Big Bang. By analyzing tiny distortions in the CMB caused by galaxy clusters moving through space, researchers discovered that many clusters appear to share a coherent velocity, moving toward a seemingly invisible force hundreds of millions of light-years away. The origin of this pull is unknown. Some theories suggest it could be the gravitational influence of massive structures beyond the observable universe, regions so far away that their light has not yet reached us. Others speculate about exotic physics, including unknown forms of matter or deviations in the large-scale structure of the cosmos. Conceptually, dark flow is deeply unsettling because it hints that our universe might be part of a larger, unseen structure, with gravitational forces acting across scales far beyond what we can observe. It challenges the idea that the universe is isotropic and homogeneous, that, on large scales, it looks roughly the same in every direction. Dark flow reminds us that despite centuries of astronomical observation, the cosmos still harbors forces and motions we cannot explain, invisible currents pulling galaxies silently across unimaginable distances. In essence, dark flow is like a cosmic whisper, a subtle motion suggesting that the universe is far stranger and more interconnected than our eyes can see. It points to the possibility of hidden realms beyond our cosmic horizon, unseen giants shaping the fate of galaxies, and forces so powerful they defy comprehension. Studying it is not just an investigation into motion, it is a journey toward understanding the deep, hidden architecture of the universe itself. Rogue black holes are among the loneliest and most mysterious travelers of the cosmos, black holes that wander through space untethered to any galaxy. Unlike the black holes we typically imagine, anchored at the center of galaxies or formed from dying stars within stellar neighborhoods, rogue black holes drift silently through the interstellar void, invisible except for the subtle effects of their immense gravity. Some are thought to have been ejected from their home galaxies during cosmic collisions or supernova explosions, while others may have formed in isolation, born from stars that never found a galactic home. Detecting these cosmic wanderers is incredibly difficult, because they emit no light. Astronomers must rely on indirect methods, such as gravitational lensing, where a rogue black hole bends the light from background stars, or through interactions with interstellar gas, which can create faint X-ray or radio emissions. Even though they are invisible to the naked eye, their existence reminds us that the universe is not static. It is a dynamic, shifting ocean where colossal objects drift in silence, unseen yet profoundly influential. Rogue black holes can vary greatly in size. Some are the remnants of massive stars, with only a few times the mass of the Sun, while others may be intermediate mass black holes or even supermassive, roaming the space between galaxies. Their journeys are slow on human timescales, but immense across cosmic time, traversing hundreds of light years and occasionally passing near other stars, where their gravity can dramatically alter orbits or even fling stars into deep space. Conceptually, rogue black holes are both haunting and awe-inspiring. They are the universe's ultimate loners, silent titans moving through darkness, invisible yet capable of influencing everything in their path. Studying them is like charting the unseen currents of a vast cosmic ocean, revealing a side of the universe that is wild, untamed, and profoundly mysterious. These wanderers remind us that space is not empty, it is a stage for giants moving in secret, shaping galaxies, stars, and the very fabric of the cosmos as they drift through the dark. TON 618 is one of the most extreme and awe-inspiring objects ever discovered in the universe, a quasar powered by a supermassive black hole of unimaginable scale. Located billions of light-years away, TON 618 hosts a black hole with a mass of roughly 66 billion times that of our Sun, making it one of the largest known in existence. To put this into perspective, our Milky Way's central black hole, Sagittarius A, asterisk, is only 4 million solar masses. TON 618 dwarfs it by a factor of over 10,000. This colossal gravitational engine drives an extraordinary quasar, emitting energy that outshines entire galaxies and illuminating the cosmos across unimaginable distances. The scale and power of TON 618 are almost impossible to comprehend. Matter spiraling into the black hole forms an accretion disk of superheated gas, releasing light and radiation across the electromagnetic spectrum. Its brightness is so extreme that TON 618 can be observed billions of light-years away, serving as a cosmic lighthouse from the early universe. Studying it gives astronomers insight not only into the formation of supermassive black holes, but also into how such objects grow to colossal sizes in the relatively short lifespan of the cosmos. TON 618 also exemplifies the limits of what the universe allows. Its mass, gravity, and energy output push the boundaries of known physics, challenging scientists to understand how such an extreme object can exist. It is a reminder that black holes are not just endpoints of stellar evolution, they are cosmic architects, capable of shaping galaxies, influencing their surroundings, and revealing the immense power hidden in the fabric of space itself. Conceptually, TON 618 is both terrifying and awe-inspiring. It is the apex of cosmic extremes, a reminder of how vast and violent the universe can be. To encounter TON 618, even from billions of light-years away, is to witness the sheer scale of creation and destruction intertwined, a monument to the universe's most formidable forces, where gravity, energy, and mass converge in a spectacle beyond human imagination. The edge of the universe is not a wall, a border, or a physical boundary. It is the limit of what we can observe, the cosmic horizon beyond which light has not had time to reach us since the beginning of the universe. The universe itself may be infinite, but the observable portion stretches only about 46.5 billion light-years in every direction, a sphere defined by the distance that light and other signals have traveled in the 13.8 billion years since the Big Bang. Beyond this horizon, the cosmos may continue indefinitely, populated by galaxies, stars, and phenomena we will likely never see. At this edge, space becomes a frontier in the truest sense. The farther we look, the farther back in time we are observing, seeing the universe as it was billions of years ago, in its infancy. Galaxies appear smaller and younger, light is redshifted as cosmic expansion stretches its wavelength, and the fabric of space itself is expanding faster than light can travel relative to us. The edge of the observable universe is, therefore, not a location but a boundary of knowledge, a limit imposed by the speed of light, time, and the age of the cosmos. This cosmic horizon carries profound implications. It suggests that much of the universe may remain forever beyond our reach, hidden behind an invisible curtain of distance and time. Phenomena like dark flow hint that even beyond our observational limits, vast structures may exist, pulling on galaxy clusters and shaping the universe in ways we cannot directly measure. The edge of the universe challenges not only our technology but also our imagination, reminding us that the cosmos is far larger and more mysterious than our senses or even our instruments can grasp. Conceptually and philosophically, the edge of the universe is humbling. It reminds us that human knowledge has limits, that the universe is vast beyond comprehension, and that the story of existence stretches far beyond the tiny bubble of space we can see. Yet, it is also inspiring. Even at the edge of observation, the universe beckons, inviting curiosity, exploration, and wonder. To study it is to acknowledge both the immensity of the cosmos and the enduring drive of humanity to reach beyond what is known, to push against the very limits of understanding and glimpse the infinite. From the great nothing to the blazing heart of Ton 618, from wandering black holes to the farthest edge of the cosmos, we've only scratched the surface of what the universe is hiding. And if this journey left you wondering what other secrets lie in the dark, trust me, the next voyage will take us even deeper. Because out there, beyond every horizon we know, is another mystery waiting to be uncovered. Stay curious, stay fearless, and get ready. The next episode of Space Frontier Ventures will take you somewhere even stranger.